Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Lili Faqihah binti Asman from AS1205I. I will be presenting along with my two group mates, Naqib Najmi bin Hishamuddin and Ainul Hakimah binti Ahmad Nazri on our final year project, which is understanding the system of hydrokinetic turbine and its impact to the environment. First things first, I will be explaining about the abstract. This paper is a study of the hydrokinetic turbine and the impact of its implementation to the environment. HK turbines are invented in order to assist in generating electricity. The turbines are known to be placed underwater in a location where the minimum flow velocity should be greater than 0.5 meter per second, as stated by Darius Hakimah and others in assessment.The riverine hydrokinetic energy resources in Lithuania. Though it is a convenient alternative where the turbine produces renewable energy by harnessing the kinetic energy of the water motion, the implications that affect the environment are questionable, as it might cause noise impact, a disturbance to the fish behavior, and also the chemical effects and toxicity of the HK turbines, as stated by Muhammad Saleh and others in 7 years hydrokinetic turbines for a sustainable river-based energy extraction, a review of the technology and potential applications in Malaysia. In this paper, around 28 research papers were selected in accordance to the study of our choice, and all were carefully read and analyzed in order to study on the various types of and mechanism of the hydrokinetic turbine, the location suited for its implementation, and its impact on the surrounding.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ainul Hakimah, and my part will be the introduction and design of hydrokinetic turbines. As we all know, global warming has received major recognition from governments, research centers, and corporations that makes and contribute especially well to sustain renewable energy resources for future generation. This is to ensure that the increase of global warming to stay under 2 degrees Celsius, since we have all been relying to fossil fuels. This explains why renewable energy resources is necessary. Therefore, this mini project gives the objectives of studying and understanding the system of hydrokinetic turbines according to its rotor installment, as well as its impact to the environment. Based on the review, systems of hydrokinetic turbines can be classified into several types. Also based on the review, hydrokinetic turbines should only be placed at specific suitable place. Next, the methodology of this review will explain about analyzing the design efficiency and rotor and blades of hydrokinetic turbines. There will also be analysis on its impact to the environment and marine life. So, based on the analysis, the result shows that hydrokinetic turbines still need to be improved on its design, such as the blades as the example. This is because it gives bad impacts to the marine life. All in all, hydrokinetic turbines still have its pros and cons. Hydrokinetic turbines can be classified into 3 types. So, the first one is the horizontal axis hydrokinetic turbine. Its rotor axis is parallel to the tidal current and it employs a propeller type of rotor. These horizontal axes have the same operating principle and design philosophies as like wind turbine. And this horizontal axis is usually used in tidal current or the ocean. Well, below pictures are the illustration of horizontal axis hydrokinetic turbines that are used in the ocean. So, the second design is called the cross-flow turbine. The cross-flow turbine is one of the earliest hydrokinetic turbine in the century, but nowadays it has been modernized to adapt with our technology. Cross-flow turbine is good to be used in tidal current and has the capability to initiate power from any flow perpendicular to its axis. It also has a rectangular cross-section, and it is stated in a research that it is a machine with uncomplicated geometry, design and construction. The good thing about cross-flow turbine is it is efficient even though with different load conditions. Now, the last design is called vertical axis hydrokinetic turbine. So vertical axis consists of normal rotor axis to the tidal current and it uses lift-drag forces. Vertical axis turbine also have several types of design, and the most known design is called Darius turbine. Different from the other two, vertical axis is suitable for small and medium river application.
Next, I will be continuing on literature review. I will be explaining about suitable locations for the implementation of hydrokinetic turbine. According to Abhinandan Barua and others in their document, Modeling for an Autonomous Hybrid Renewable Energy System for Electrification of a Township, locations with a complex terrain with hills and rainforests, they're more vulnerable to natural calamities that can bring occasional damage of transmission wires and transformers along the region. And some regions are unfortunate enough to experience the degradation of agricultural and forestry lands, water quality deterioration, soil attrition, landslides and floods. So, in order to avoid such detrimental effects, it is very important to find an optimum river flow in order to make sure that the riverine ecosystem is sustainable. According to Darius Hakimah and others, there are some methods that should be considered when implementing hydrokinetic energy as a renewable resource. That is to say, these methods are related to social, environmental and technical favors. The required minimal values of these factors in different literature sources contrast significantly, where it is recommended that flow velocity of the river current should be greater than 0.5 meter per second, and the flow depth must be at least 0.5 to 0.75 meter. Darius Hakimah and others also stated that hydrokinetic turbines are proposed or suggested as primary source of energy supply in rural areas and remote communities. This further proves that rivers with optimal flow and rural areas are suited to implement the use of hydrokinetic turbine. Badrul Saleh and others in 7 years hydrokinetic turbines for sustainable river-based energy extraction, a review of the technology and potential applications in Malaysia, they also stated that amongst the various types of vertical axis hydrokinetic turbines, the one that is considered the most suitable for river current applications is 7 years turbine, as it provides a sustainable electrical power supply. The important reason for using this turbine is because it offers a simpler system design, which consequently leads to a lower development cost in comparison to other types of vertical axis turbines. This turbine is economically fitting for low-income communities in remote areas, in rural areas in Malaysia. And usually these areas are living in close proximity to rivers, of course. The brief explanation on analysis. The analysis that can be made about hydrokinetic turbines is that it is basing on the conversion of hydrokinetic turbines works by converting kinetic energy of moving water in rivers, channels, tides, or ocean currents, and it stands out as a promising technology as a technology that will be very useful in the future. The environmental impact of hydrokinetic generation is much lesser than that of a conventional hydraulic generation, since they require less intrusive construction projects and thus have a diminished environmental footprint.
Hi, I am Muhammad Naqib Najmi and will be presenting about the methodology, result and discussion and also conclusion. For the methodology, first point we have the hydrokinetic turbine design. Hydrokinetic turbine are known to have a same design as the wind turbine, but hydrokinetic turbine are designed to capture or extract only portion of kinetic energy of water pass through a cross-section maximum power extraction. The objective of the process turbine design are maximize hydraulic performance, minimize sensitivity to economical costs and cavitation and sounding, provide sufficient thickness for bending stiffness, and incorporate adequate sound pressure. There are laboratory tests about hydraulic performance where the plate element method are widely used to minimize the axial momentum imparted while maximizing the percentage power coefficient. There are also, apart from the blade element method, there are also rotor design, which is to determine the cone and twisted distribution along the span of the blade. The example of rotor design are rotor diameter, tip speed, aerofoil, water current, velocity, and etc. Next point, we have study side of the hydrokinetic turbine impacts. So there are potential of environment effect associated in hydrokinetic turbine device. It could be physical interaction of environment, either direct or indirect effects like sounding and noise from the hydrokinetic turbine, affecting to the fish behavior, effects from the hydrokinetic turbine electromagnetic fields, and effect of the chemical and toxicity. The study set from the hydrokinetic turbine sound exposure conclude that the experiments are easy to understand about the interpretation of the volume distance from the turbine. The sound exposure are to study the behavior species of fish in the water when the hydrokinetic turbine occur. For the result and discussion, there are impact occur in the environment and the marine life. For the effect of rotor to the fish movement are shown by the fish passage through rotor field are heavily reduced. It also shown there are significant more gap passage when the rotor was absent compared to compression occasion. Beside rotor, there are blade strike, which is also affecting injury to the fish after correction take place. This is because the mechanism that make fish vulnerable to predation from the other fish overweight. For the electromagnetic fields, it gave effect to marine life and extraction species. As you can see from the picture here, dungeon crab at life state of juvenile or adults, it could be avoidance or attraction to the electromagnetic fields. The crab will change in mating, foraging, migration, predator or prey interaction affect survival, distribution and also abundance. Sound exposure from the hydrokinetic turbine are shown for the fish behavior mix indicate of avoidant response to it. The study state the fish species are often classified as either hearing generalists or specialists based on the presence of morphological hearing specialization and range of hearing sensitivity. Move on to the point 2, which is the probability that could happen. There are additional emission of sound, light, and electromagnetic field come from the hydrokinetic turbine installation. The rotor blade also can cause a different kind of injury because of the blade, the animal, and the concentration condition. Fish with low mass and initial substance get less physical injury than large heavy animal at the strike blade. For the economical system, there are state foreign company have a maximum cost calculated. There are also the financial costs permitting a much more disincentive for small hydrokinetic turbine project than there would be for large-scale wind or fossil fuel project. For the conclusion, we can conclude there are still more to improve about the hydrokinetic turbine deployment and development. The improvements, we hope that it could lower the risk for stability, also lower the cost, economical if possible, because the hydrokinetic turbine could benefits to our environment as a renewable energy, also new future development for the engineering benefit and other related applications.
Lastly, these are all the references that we use to write the informations on our paper review and analysis. Most of these references are obtained from UiTM Library's Corpus Access. Finally, we hope you enjoy our video presentation and thank you for watching.